Let me present a report approach to solve the problems of filtration and extrapolation in the construction of functionality stable stochastic system with delay by Viktor Chumakevych, Ivan Dyyak, Victoria Chumakevych, Igor Puleko, and Vadym Ptashnyk. Functional stability theory organized in the 1980s and was used to control complex dynamic objects and computing systems. This theory makes it possible to respond promptly system and block failures to reducible and the functions of the valid block between those capable of performing the final task. The peculiarity of the theory application in the number of requirements to be might be the system of its application. First, the simple linear differential equations were used as mathematical models and then a mathematical component was added, which made it possible to particularly take into account the peculiarities of real system functioning. In the general case, the homogeneous difference system which state vector z characteristic functions a, b during the mathematical process W can be described by the equations first. In previous study, there was obtained the equations for the conditionality optimal extrapolated based on expansion in terms of Hermite polynomials. Second, it has been also concluded that it is possible to available the accuracy of filtration extrapolation process and the comparing different filters based on the proposed mathematical prepares. With the widespread use of the computerized control systems, mathematical decrease systems have developed significantly. On the sampling interval t at the instance of time tk, the state vector value zk and the random vector value vk with the function pk, it is advised to describe using the different equations thus. The state vector zk has an initial value z0 and does not depend on the equation that described of the domain of state of the system vk. In the previous studies, there were considered two peculiarities of this process for simple decrease and discrete continuational system using the method of the quasi-moments and orthogonal explanations. It is also possible to solve the problems of filtration and extrapolation for such system. By their notation, the following solutions correlate with previous studies, as you see. Barbation and Gelination have worked out the solution for such system. Modern complex dynamical systems such as aircraft system, electromechanical system, etc. have a more complex structures. They include the status calculation and actuators. Thus, it is expense to describe them using stochastic decreed system which delay limited or unlimited under expected operation conditions. All the above models are defined by Markov random process in the case of the Markov process being able to serve as a corresponding mathematical model of the system with a consecution. Offer a more general stochastic different equations as in adequate mathematical models of the systems. Fourth, in struct to first A and B, the functionals of z tau on a given interval, functionals of elementary available omega, measurable for such which respect to sigma algebra deduced by the values of a random process z tau, or what it is the same by the value of a random process w tau, corresponding to all given interval by set t0t in equations first, the value set 0 tau of the 0 tau process for this interval in the denoted. Those models are called stochastical systems with unlimited delay. As the example of the systematical such models, equation force can serve with pipes, where theta is determined by the following integral equation 6. In 5 and 6, A, B are functionals mapping on a given area and responsibly A in the functions mapping on a given area to P RP. B is a function mapping on a given area to P RPQ. The second integral in 6 is stochastic integral. In modeling stochastical system with limited delay, there are a number of peculiarities. A stochastical system with limited delay is the special case of the stochastical system with unlimited delay and described by the stochastical difference equation of the following four statements. Under the given considerations. This class of stochastical system requires special method of study. It is assigned the stochastical equations for sevens with corresponding initial considered have solutions that correspond to stable dynamical systems. Let us begin to consideration with stochastical system with unlimited delay. It is not possible to derive the general in the equation of finite dimensions distribution of the state vector of the system force. However, for a wide class of system equation, force 6 can be required stochastical differential equations. Let us first consider the symmetrical system for 6 for a case when the functions a and b have the following form A's, where G and gamma, as you see. In practice, the kernels G and gamma usually satisfy the following conclusion: physical facility 9 and 10 under the given condition. For stationary kernels, G and gamma, the Laplace transformation in this case responds to rational function of a complex variable C, etc. The following representatives hold 11th. The initial stochastic symbol for 6 and 8 can be reduced to the following stochastic difference system 12. Here, P, A, QP and the arithmetic rational operation of the ninth orders M and KL respectively. Applying the known methods of the theory of the linear systems, the last two equals of equations 12 can be reduced to the Cauchy form by expected of the state vector with their subsequent presentation in the form of symmetrical different equations. As a result, symmetrical system for 6 will be required to the systematical difference system 12, which non-stationary operator Pt, Ht, Qt, Pt for a y class for a more complex function a and b. In 6, the approximation of the form is often used such as in practice, due in the inferior of period information, the functions a and b are usually known approximately. Therefore, they can almost always be approximated by the formula A with formula G and gamma of the one of the two able types. After that, by means of the suggestion about methods, equations 4, 6 are reduced to systematical different equations of the form 12. Another special case when mathematical systems for 6 can be reduced to mathematical different system for the form first by expansion of the state vector. In the case where the formula H functionation H and B, all of the following representation 14th, a sum Z 15th. It is possible to reduce the initial stochastic system to the following stochastic differential 1/60th. Let us consider stochastic system with linear delay. Any stochastic system with delay of the form 7 is the case of the systems 4, 6, where the function a of 6 is the linear function z and its coefficient of delta function of the form delta and b. It is clear that none of the available considered approximation is approaches to those systems. Special methods should be developed here. In practical problem for the nullity of the system which delays the transfer function of the link with poor delay of offer approximated. 70s. Using this approximation, introduce a new variable y first ym that satisfies the following differential equations 80s. Then equation 7 in response by equations 80s, 90s. Equation 80s, 90s with initial consideration 20. Describes stochastic different system that approximated the system with delay 7, substituting 7s by equations 80s, 90s, any of the above methods for the approximation determination of finite determinational distribution of the system's Stochastic vector can be used. To approach to the real time with limited computer power, there is a recommendation to the use concatenation optimal filters. We will use simple filters, for example, to develop the solution of difference equation, which can serve as the example of filters and meet the requirements of simplicity of calculations. For our case, we can use the following approach: 21st, 20 seconds. Under given conditions. Concurrently, optimal filters for decried stochastical system. For optimizations of delta k gamma k in equations 22nd, the linear rule mean square requirements of the Welle equations or the k plus g plus 1 on a random vector c is found. The standard method learns the following equations source were 24. To calculate the mathematical expectation of the formula in this case of the filters problem J equation 1, 0, let us apply source and use the equation 25, which no function G1 lambda is limited consideration 26. This theorem is the extension of optimal control for the complex dynamical object figure 1 by means of a special device figure 2 using the specialization filter figure 3 has been provided. Consider the feature in such system in consider of limited computer resource and real time, which is adhered to the operation of a large number of mobile systems. The algorithm of identically includes the residual of the form 27, 28. The required identification algorithm can be written as 29. Specified technical algorithm you can see here. Differ from each other to be again matrix gamma 1, the dimensional vector theta, and by the observation vector Z1 and conclusions. The joint solution of the obtained equations 27, 28, 29 and such determines the conditionally optimal extrapolator. System of equations can be solved using an approximation method. Any of the above can be used to this purpose. The identification algorithms are generated by minimization the correspondentional quadrical and wider quadrical criteria of residual. And finally, the optimal identification and adjustment algorithm correspond to the minimum of the samples error covariable matrix, which is the criteria of convergence rate. Trust in contextually stable system, optimization should be carried out according to several optimality criteria. The basic structure of the system has to be meet to the minimum of the quadratic error criterions. The predicational structures have to mean a minimum of the predicational criteria. Thanks for your attention.